This is a long lecture, the longest in the entire course and one of the most mathematical. But finally, we have arrived at the point of introducing neighborhood method. Up to this point, everything we talk about is about individual row or individual column in the movie user rating table or matrix. But now we are ready to go into the global structures. And the way we go into the global structure is by defining a neighborhood Li for each, say, movie I. We can also look at this from a user point of view. We'll instead just focus on the movie-movie correlation. So you can think of two columns representing the two movies. And we want to look at how different they are. In other words, define a pairwise statistical correlation between the two movies. And then we look at another pair of movie, still movie I, but instead of comparing with movie J, we compare with movie K. And look at the ratings from between this and this two columns. And then we're going to pick up all those movies that are somehow very similar or very dissimilar compared to movie I. Both kinds of movies will be very useful. So this is what we're going to do. We first define a similarity metric between two movies, and then we will search through all the movies out there and then pick up a subset of those that are either very similar or very dissimilar compared to movie I and call that the neighborhood Li. And we leverage that global information in making predictions about users liking or disliking this movie I. So this idea can be illustrated quite nicely through a simple picture. Suppose we've got just two movies and two users. So we can easily compare 2 points on 2D grid. The 2 points are the movies A and B, and we've got two users, 1 and 2. The points are the movies, and the x's are the users. So movie A is getting a rating of 5 from user 1 and 1 from user 2. So movie A is getting a 5-star and then a 1-star from these two users, whereas movie B is getting a 2-star and a 5-star from these two users respectively. As you can tell, that these two movies are kind of very different. Okay, they are basically liked or disliked in an opposite polarity by these two users. And indeed, this means that this angle theta is kind of big. What is this angle? This is the angle between two straight lines. One is the line from the origin to this movie's coordinate, and the other is from the origin to this movie's coordinate. And if these two coordinates are far apart, one quantification of that is the angle theta here. If we measure the cosine of that angle, that is a particular number, and we use that number to describe how similar or dissimilar A-B movies are. This is called cosine coefficient. It is a particular instance of similarity metric that we'll be using here. So how do we write down the cosine coefficient here? I'm going to say the cosine coefficient between two movies ij is called dij, and if you remember from basic geometry, analytic geometry, it's really this point viewed as a vector from origin to that point. Okay, call that a vector Ri. It's a vector transpose Rj, that is this point viewed as a vector from the origin to that point, divided by the normalizations, that is the size of I, L2 norm, and the size of J, also L2 norm. So we can view these two ratings for two different movies as two vectors, Ri and Rj, and the cosine of the angle is the standard formula, which is just their inner product normalized by the sizes. And this in the longer form just means Rui and Ruj summing over all the U's who have rated both movies I and J, that is. That is the inner product of these two vectors, divided by the square root of, just by the definition of L2 norm of the two vectors, Rui squared summing over all the u's, it's the same set of u as here in the numerator, and summing over the same set of u are uj squared. That's just the L2 norm of these two vectors. So this dij is the cosine coefficient defined as such geometrically as the cosine of the angle theta and algebraically defined as such. Now, because we have already shifted the R data from R to R minus the baseline predictor R for each UI pair, we call this R2D UI at the end of the last segment of the video. So strictly speaking, we should put 2D here. So all looking at the R2D value that has already subtracted the influence of the baseline predictor. So now what we need to do is to look at all the pairs of movies ij except movie ii back to itself, and then compute this relationship.